Okay. So basically in previous class, I mean in yesterday class, what are the topic we cover? We cover about the VLAN, right? We cover about the VLAN, why we need VLAN, right? And how to configure the VLAN, right? And how we move the ports into the VLAN, right? So basically, these are the topic we cover in our yesterday class, right? Now, in today's class, we are going to discuss something more. For example, we have this topology. Try to focus here. We have this topology, and in this topology, again we have a three different client. For example, that is the IT, that is the HR, and this is, for example, sales department. So basically, right now there are how many departments? Three different departments. IT department is using the network ID 192.168.1.0. HR is using 192.168.1.64, and this sales department is using 192.168.1.128. Fine. So these are the three different department. Clear? And these are the three different network ID also. If you have knowledge about the subnetting, you can calculate it. Then, so these are the three different network. Now, this all the PCs are connected with the switch, that is the L2 switch. And this is connected with again the switch, and this is connected with again the switch. Now, what we need to do, we need to make communication possible. Now, the first thing, if I ask you very simple question, if I remove this part, if I remove this part, can you make communication possible here by the help of this L2 switch from this network ID to this network ID, or from this department to this department? Answer is no. We can't make communication possible from one network to another network by the help of L2 switch, right? Because I already told you in yesterday class why. Now, because see, IT department is in the different network, HR is in different network, and this is the sales is in different network. So that is not possible. Now what I did, I connect one L3 device here. What I did, I connect one L3 device here, that is router. And with this L3 device, I connect one, two, three. Three links are there. One link is in this network, second link this network, third link in this network. Clear? Understand? So what I did, one link is in this network, second link this one, third one this one. Clear? And I connect total three links here. So here, come here on this device. On this device, I configure the IP address 192.168.1.1.1. Here I configure 192.168.1.1/26. Here I configure this IP address. Here I configure .2 and here I configure .3. But in yesterday class, I told you one thing. If you are trying to ping from one network to another network, if you are trying to ping from one network to another network, your PC will perform A and D operation, right? And according to the A and D operation, your PC will now understand, oh, you are pinging different network. It means I need to forward your packet towards the default gateway. It means you need to provide here default gateway. But tell me, is it possible to provide the default gateway on L2 switch? Answer is no. Because on L2 switch, you can't configure the IP address on the interface. Right? In yesterday class, I told you. Right? So, if you want to provide the default gateway, you need any L3 device. So that's the reason I use here one router. Now what I did, I connect one, two, three link is there. And this is the link. That link is the part of this network. And here I assign 192.168.1.62. This is the IP address I assign here. And this IP address will be the default gateway for all the PC here in this network. This is the IP. That IP will work as a default gateway for all the three PC here. Done. In the same way, here I assign 192.168.1.65, 1.66, and here on this interface I assign 192.168.1.126, and that will be the default gateway for all these two PC. Clear? Similarly, here I assign 192.168, 1.129, 130, and 131. And here I assign 192.168, 1.190. And this will be the default gateway for these three PC. Clear? So now I hope you understand for these three PC, the default gateway is 192.168, 1.1.62. That is configured here. And for these two PC, the default gateway is 192.168, 1.126. That is configured here. And for these three PC, default gateway is 192.168, 1.190. That is configured here. Clear? Understand? So now I already provide the default gateway. So what will happen? For example, if you ping from this PC to this PC, if you ping from this PC to this PC, what will happen? This PC will generate the packet reach here. What switch will do? Switch will forward the packet towards the router. Router receive your packet here. Router receive your packet here. Getting my point? Now, what you need to do? What you need to do? This router receive the packet here. What router needs to do? Router will perform the routing. Router will perform the routing and router will forward your packet. For example, if you are pinging this network, router will forward your packet through this one and like this. This is the way actually the packet will flow. This is the way actually the packet will flow. I can show you. See here. ICMP here. Let me check IP address is configured or not. Enable show IP interface brief. See, there are how many interface? Three interface. 192.168, 1.62 on 0 by 0 that is configured. On 0 by 1, 1.126 is configured and 0 by 2 here configured 192, 190. Done. And all are up. There is no problem. Clear? Now these are the three PCs. Let me check on the PC. On PC IP address is configured, default gateway is configured. Everything is set. Done. Now come to the switch. On switch, you need to configure the VLAN, right? On switch, what you need to do? You need to configure the VLAN. Clear? For example, that is the IT team. IT team is the part of, for example, VLAN number 10. IT team is the part of VLAN number 10. So I write here VLAN 10. And for example, HR team. Where is HR? HR team. HR team is the part of VLAN 20. So this is VLAN 20. And this is sales team. So for sales team, that is part of VLAN number, for example, 30. So that is 30. Fine. So come to the switch. On switch, first of all, you need to check, do we have VLAN? What is the command to check the VLAN? So VLAN. So VLAN. See here. VLAN number 10, VLAN number 20 and VLAN number 30 are there. Three VLANs are already configured there. Clear? Now, see, all the ports are already moved. Now, let me cross check. See here, come with the IT VLAN. In IT VLAN, these are the three ports is the part of which VLAN? VLAN number 10. This is the our three department. Yes, all the three department are in the different network. All the three department is in the different network. Okay. Now what I did, all the three ports is the part of VLAN number 10. So see na, 0 by 1, 0 by 2 and 0 by 3. These three ports is the part of VLAN number 10, right? And on this switch, there is a one more port, right? I mean this port, this one. So this is for VLAN number 10. So I need to move this port also in VLAN number 10. Clear? So that's the reason I move here. Fast Ethernet 0 by 1, 0 by 2, 0 by 3 in VLAN number 10. And I think this is 0 by 9. So this is 0 by 9 is also the part of VLAN number 10. Done. Similarly, guys, you need to configure this one. HR. HR is VLAN number 20. So I created VLAN number 20 here, and in VLAN number 20, 0 by 5, 4 and 5. 0 by 4 and 5. This is 0 by 4. This is 0 by 4 and this is 0 by 5. Both are part of VLAN number 20. And this port you need to move in the VLAN number 20. So that is 0 by 10. So that this is also in VLAN number 20. Fine. And rest all the ports is in VLAN number 30. Clear? So this is the way I configure the VLAN here. I hope you understand, right? So VLAN is also configured. For example, now you go onto the PC and go to the command prompt. If you are writing ping, for example, you are pinging from this PC number 1 to here this PC number 6. What is the IP address? 192.168.1.129. 129. You are pinging this PC. So it generate the packet, right? So let me open this packet. When you see the packet, this is the ARP. This is the ARP because this PC don't know the destination device MAC address, right? And in yesterday class, I told you if you are pinging in the different network, your PC will find out, your PC will calculate the MAC address of your default gateway because you know if you are using the L3 device, L3 device is not going to forward your ARP packet from one network to another network because right now this PC is the part of 192.168.1.0 and the destination which you are pinging, this is the part of 192.168.1.128. Both are in the different network. So your ARP will not go from this network to this network. It means your ARP will find out the MAC address of your default gateway. So what is your default gateway? 192.168.1.62. That is the default gateway. So basically this ARP will find out the MAC address of your default gateway. Clear? I hope this is clear to all of you. Fine. Now see, this send the packet reach onto the switch. What switch will do? See, switch forward this packet here. I told you switch will switch check. I am receiving this packet on which interface? On this interface. And this interface is the part of which VLAN? VLAN number 10. So switch will forward this packet through all the interface which is the part of VLAN number 10. So these two ports is also part of VLAN number 10 and this is also part of VLAN number 10, right? So that's the reason this switch is forwarding your packet here, here and here. Understand? Clear? So this router received the packet. See here, when I open, that is the inbound. Inbound means this router receive it. Clear? Now, outbound. In this outbound, see, what is the source address? Source address is B001. What is source MAC address is B001. That is the MAC address of which interface? That is the MAC address of router, this interface, this one, first one. Clear? 0 by 0. For example, go to the router and if I write, so interface gig 0 by 0. So see na, B001. B001. See na, match it. B001 here and here, right? So basically this is nothing. This is the MAC address of this interface. Okay. So this router send the packet again to the switch forward the packet towards the PC. Now this PC know what is the default gateway MAC address. Now this PC will send the ICMP packet. ICMP packet will reach here switch forward this packet to the router, right? Now router will open this packet. Router will open this packet and router will check. I do not have MAC address of the device which you are pinging. You are pinging this device, right? You are pinging this device from this device. So first of all, what happened? ARP exchange. What happened? ARP exchange from here to here, right? Now again, there will be one more ARP exchange between here and here because your router don't know what is the MAC address of this device. Getting my point? So that's the reason this router is generating the ARP packet. Which packet? ARP packet. Clear? Understand? Clear na? Is this clear? So when you open this packet, see in this packet, what you are able to see, the destination is FFF. Now again, there is a very important interview question. I told you, router never forward your ARP packet or router never forward the broadcast packet, right? I already told you, router never forward your broadcast packet. But please remember, router can generate the broadcast packet. See now, right now, this is the router. But router is generating the ARP packet. And that is the broadcast packet. Okay, na? So that is very important. Clear? Now this router send the ARP request to the switch. Switch forward this packet through all the all the interface. All the interface. See very carefully. When router is sending the packet, router is sending the ARP packet. But now, on which interface? On which interface? See here. See very carefully. When this device, when this device when this device send the, for example, ICMP packet come here, switch receive this packet on this interface. This interface is the part of VLAN number 10. This will forward your packet through all the interface which is the part of VLAN number 10. So switch is forwarding this packet through first link here. Router receive your packet here. What router will check? Router will check in your ICMP packet. Router will check source IP, destination IP. Source IP will be, guys, 192.168.1.0 or 1.1. 1.1. It means that belongs to which network? 1.0 network, right? Destination IP will be 192.168.168. 1 dot, what is that destination? What is that? 128. 1.128. That is the destination. Agree everyone? Yes or no? Tell me. Right? When you open this packet, see na, in the source, destination is 1.129. It means it belongs to which network? This network. Right? Now, what this router will do? This router will check the routing table. This router will check the which table. I told you na, router perform the routing. So IP route. This router will check the routing table. And in this routing table, this router will find, hey, I have this entry in my routing table. 192.168.1.128/26. That is the network ID. And that network ID is connected on which interface? 0 by 2 interface. On which interface? 0 by 2 interface. And where is 0 by 2 interface? First one is gig 0 by 0. Second one is gig 0 by 1. And third one is called 0 by 2. Fine. So that's the reason your router is forwarding your packet. Your router is forwarding your packet through this interface. Third one. And switch is receiving your packet on this interface. Now again, what switch will check? Switch will check I am receiving this packet here on the third one. On the third one. And switch will check this interface is the part of which VLAN? Tell me guys, first one is part of VLAN 10. Second one is the part of VLAN 20. And the third one is the part of VLAN 30. Right? Now switch will check I am receiving this packet on the third interface. And this interface is the part of VLAN number 30. Fine. And that is the broadcast packet because this is the ARP packet. Now switch will forward this packet through all the interface which is the part of VLAN 30. So switch is forwarding here, here and here. Clear? Understand guys? Everyone. That is very important concept. Clear? So see here, packet reach onto the switch. On the third interface, switch is forwarding this packet like this. Clear? All these two PC will drop this packet because destination IP address will not match. This PC will receive. So this PC will send the reply. Reply come to the switch. Switch forward this packet to the router. Clear? Now this router will know what is the MAC address of this device. Now this router know what is the MAC address of this device. So IP ARP. See, when you open the ARP table on the router, the destination device that you ping, that is 192.168.1.129, right? Now see na, for 129, this router have MAC address now. There is no problem. Clear? I hope this is clear to all of you. Everyone, done? Now see. Okay. Say here on this PC, this is the ICMP sequence number 2. That is the second ICMP packet this PC is generating. Okay. Come here, packet reach here on the switch. Switch is forwarding this packet. Switch receive this packet on which link? This link. This link is the part of VLAN number 10. This link is the part of VLAN number 10. Clear na? Everyone, yes or no? When you open this packet, see here. This link is the part of VLAN number 10. Clear? So this is VLAN number 10. Switch is forwarding this packet through the which link? First link to the router. Done. What router will do? Router will forward this packet to the switch. Yes or no? Right? Switch receive this packet. Switch receive this packet and switch will forward this packet towards here. Clear na? So basically guys, this is the packet flow. This is the packet flow. I hope you guys understand how actually the communication is happening from here to here. Is this clear everyone? Yes or no? Done? Clear? Now see here. Here there is a one challenges. The challenges is right now, if you are trying to ping from here to here, I mean from one network to different network or from one VLAN to different VLAN, what you need? You need a L3 device. You need a L3 device. Okay, that is the thing. Now second thing is, see here between the router and between the switches, how many links you are using? You are using the three different link because right now you have a how many VLAN? You have a 3 VLAN, and for each VLAN you are using the different link. Getting my point everyone? Yes or no? Right? That is the problem. That is the problem. Why we use the for different VLAN different link? For example, in the real-time company, if you go, there will be a 100 number of VLANs. So for every VLAN, are we use the different link? That is not the solution. That is not the solution. Getting my point, everyone? Yes or no? That is not the solution. Getting my point? So we need to solve this problem because that is not feasible. That is not feasible. Getting my point? I hope you guys understand. Clear? Yes, that is not possible. Now see this topology. In this topology again, we have everything. See, we have IT department, different network. We have sales department, different network, HR department, different network, and again IT department with different network. Getting my point, everyone? Yes or no? Right now, that is in different network. Clear? So here we are using 192.168.1.0/26. Here we are using 192.168.1.0/26. It means both are same department. So here and here we are using the same network ID. There is no problem. But here and here both are in the different one. Both are here with the different one. But tell me one thing. For example, if this HR wants to ping, for example, any IT person, when you see guys, on this switch, who is connected? IT department is connected and HR department is connected. With this switch, who is connected? IT department is connected and sales department is connected. Getting my point? Yes or no? Right? But on switch number 1, is there any HR connected? Answer is no. There is no HR connected. But if I ask you, can you ping from here to here? Answer is yes, you can ping. What is the reason? The reason is if HR is the part of VLAN number 20 and this one IT is the part of VLAN number 10. HR is the part of different network ID. IT is the part of different network ID, but still we are able to ping. The answer is because we have L3 device. We have L3 device. Getting my point? And here between the switches and router, how many links you are using? 1, 2, 3. 3 links are there. One link will be for VLAN 10, one link will be for VLAN 20, and the third link will be for VLAN number 30. Getting my point, everyone? Yes or no? Right? Now, again here, between these two switches, we have a how many link? Two link is there. One link for VLAN 10 and one link for VLAN number 30. There is no link for VLAN number 20. But my question is, can we ping? But my very simple question, if I try to ping from here to here, can we ping? There is no link for VLAN number 20. But yes, still you can ping. There is no problem. Still you can ping. There is no problem. For example, I come here, go to the desktop, command prompt. I am writing, for example, ping 192.168.1.1. 1.1. 192.168.1.1. Here, packet generate, packet reach onto the don't know where. Maybe there is no configuration or something. Let me check. Yes, not able to ping because IP address is not configured here. Okay. Now, yes, but we can ping. You guys can do this practical. You can ping. See here how. For example, when you ping, what is the source IP address? Source IP address will be, guys, 192.168.1.65. Here, that is the source IP. Destination IP will be, guys, 192.168.1.1. That is the destination IP address. This is the packet which receive on this interface. Done. Switch receive on this interface. Switch will check this port is the part of which VLAN. Now this switch will realize कि, oh, this port is the part of VLAN number 20 because HR is the part of VLAN number 20, guys. Yes or no? Right? So, sorry, what? So if there is no layer 3 device, is it not going to ping? How it is possible if you do not have a L3 device? I told you in the study class, if we do not have a L3 device, we can't ping from one network to another network. That is not possible. Switch is not going to perform the routing. Getting my point? If you try to ping from one network to another, you need routing. You need to perform routing. Does switch perform routing? No. Okay, guys. So switch received this packet here. Switch will check. I am receiving this packet on this port and this port is the part of VLAN number 20. So this switch will forward your packet through the interface that is the part of VLAN number 20. So here how many links are there? 3 links are there. Yes or no? The first link is the part of VLAN number 10. Second link is the part of VLAN number 20. And the third link is the part of VLAN number 30. Switch will forward your packet with the second link here. Router. Router receive this packet on this interface. Router check in this packet. Source IP address is 192.168.1.65 and the destination IP address is 192.168.1.1. Router will check what is the destination IP address. Now what router will check? Router will take the forwarding decision. But how? Router will check the routing table. Router will check the routing table. So IP root. See, router will check the routing table. In the routing table, do you guys able to see 192.168 1.1 network? 192.168 1.1 network. See here very carefully. 192.168.1.0/26. That is the network you configure na everyone here. Yes or no? Right? This is the network on router. And this network is connected on which interface? Gig 0 by 0. I mean the first one. So this router will forward your packet to the first link. Packet reach here onto the switch. Switch receive this packet on the first interface. On which interface, guys? First interface here. Now this switch will check. I am receiving this packet on this interface. This interface is the part of which VLAN? Switch will understand. Oh, this interface is the part of VLAN number 10. So switch will forward this packet through all the interface which is the part of VLAN number 10. But right now, how many interface is the part of VLAN 10? Only this one. Only this interface is the part of VLAN number 10. Switch will forward this packet by this interface and packet will reach onto the switch on this interface. Now, what this switch will do? Switch will check, oh, this is the packet I am receiving on this interface. And this interface is the part of which VLAN? VLAN number 10. Switch will forward this packet through the interface which is the part of VLAN number 10. Getting my point, everyone? Yes or no? Right? And these two is the part of VLAN number 10 only. Right? Switch will forward your packet like this. I hope now you guys understand how actually the packet will flow here. Clear, guys? Everyone, anyone here who don't understand? Is this clear? Yes, this is the way. Let me configure this IP address. I don't know everything is configured there or not, but let me check. IP address, for example, I am configuring 192.168.1.65. Subnet mask, this one. Just a minute, guys. Okay, cool. Yes. So here I configure, guys, 192.168 1.65 because here 65 is there. Okay. Now after that, when I click here, by default subnet mask is /24, but I don't think we are using /24. We are using /26. So for /26, what is the subnet mask, guys? /255 255 255 dot 192. That will be the subnet mask here. Now, what will be the default gateway? Default gateway will be, guys, I told you, this IP interface will be the default gateway. This IP address will be the default gateway. Clear? So what is the default gateway, guys? There we configure default gateway 192.168.1.12126. That is the default gateway I configure there. Done. IP address is configured here. Done. Now, let me check. Can we ping 192.168 1.1? Packet reach here. Two packet here. One is ARP. See, one is ARP. ARP is broadcast. ARP is broadcast. Done. It came here. It is sending the ICMP packet. ICMP packet will reach on the router. Let me check. This is ICMP packet. Source IP is 192.168 1.65. Destination is 1.1. Done. Now, open this packet. This is the ARP packet. Clear? First of all, guys, ARP will exchange. Okay, na? So see, na, ARP is exchange here. ARP exchange, ARP exchange, everything. We need to discuss ICMP only. See, this is the packet. Come here. ICMP packet. Source IP 192.168 1.65. Destination IP is 192.168 1.1. Packet reach onto the switch. Switch forward this packet to the router. Fine. What router is doing? Router is sending the packet here. Switch is again broadcasting this packet. Switch is again broadcasting this packet. Definitely there is no. Let me check. Show VLAN. Do we have VLAN? See, on switch, we didn't configure any VLAN. So if we do not configure the VLAN, how communication will happen? That is not possible. Is this clear, guys? Everyone, yes or no? Right? I will share this lab with all of you. You guys can do this lab and you guys can practice. Okay. So here I configure the IP address and default gateway, but still here you need to configure the VLAN. Getting my point? You need to configure the VLAN. Clear? You need to configure here three VLAN. VLAN 10, 20, and 30. Clear? Move this port in VLAN number 10, this port VLAN number 20, this port in VLAN number 30. Done? Now, these three ports in VLAN number again 10. Fine. This port is in VLAN number 20. Clear? This port in VLAN number 10 and this port in VLAN number 30. Again, you need to create here three VLAN. VLAN 10, 20, and 30. Done. These two ports in VLAN number 10. These two ports in VLAN number 30. Clear? And after that, try to ping. Getting my point and observe the packet flow. Clear? Everyone, I hope you guys understand. Understand, guys? Everyone. Is this clear to all of you? Yes. Cool. But still, guys, in this topology, there is a problem. Problem is for different VLAN. How many physical links we are using? We are using different links for every VLAN. That is the problem. That is the problem. Getting my point, everyone? Yes or no? Yes, no, that is the problem. Because for every different VLANs, we are using different links. Clear, guys? Everyone? Yes or no? Done? Now, to solve this problem, we have a concept of trunking. We have a concept of, guys, trunking. What is trunking? Who can tell me? What do you mean by trunking? What is trunking and what is the use of trunking? What is trunking? So please remember a trunk refers to a communication channel or link that is designed to carry the traffic of multiple VLANs. It means now if you configure the trunk, in this case, you do not need to use different physical cables, different physical links for every VLAN. It means one physical link is able to make communication possible for different VLANs. Okay, so one link can carry different VLANs data. There is no problem. Clear? But before trunk, what we are doing? We have a, for example, if we have a three VLANs, then definitely there was a three different link. But if you use the trunk, then only one link can carry all the VLANs data. There is no problem. Getting my point, everyone? So I hope you guys understand what is the use of trunk. Clear, guys? Everyone. So basically that is the use of trunk. So trunk are primarily used to interconnect switches. And one more thing, for example, if anyone asks you the very basic question, for example, that is the switch. That is the switch number 2. Here is PC number 1 and here is PC number 2. I ask you connect all the device like this. Please remember, between the switches, always we are using the trunk link. And between the switches and the device, that is not the trunk. That is not the trunk. That is called access link. Please remember. Which link? Access link. So now again you guys will ask, okay, sir, what do you mean by trunk link and what do you mean by access link? So please remember, trunk is the link that carry multiple VLANs with a single physical link. Here we have a one physical link, and with this physical link, all the VLANs can travel. There is no problem. But what do you mean by access link? Access link means it carry only one VLAN. It carry only one VLAN. For example, if this is the access link, here on this port you configure, for example, VLAN number 10. It means by this link only VLAN number 10 data will exchange. If you try to send VLAN number 20 or something, it is not possible. But here by the trunk link, you can send 10, 20, 30, 40, 50, every VLANs. There is no problem. So I hope you guys understand what do you mean by trunk and access link. Trunk link means the link that carry all the VLAN data. And the access link means the link that carry only a specific VLAN data. Clear? Now, that is something link. If I ask you what do you mean by trunk port and what do you mean by access port? Same answer. Trunk port means the port that can receive, or by this port, by this interface, you can send the multiple VLANs data. And the access port means on this port you can send and or receive only a specific VLAN data. That is called access port. Clear? So now, what was the problem? If we do not have a trunking, then what was the problem? The first one is our topology was little bit complex. Right now, everyone, yes or no? Right? But see now previously between the switches and router, we have a 3 different link. Yes or no? For VLAN 10, 20 and 30. But now we have a only single link. At that time between the switches, we have a 2 link for VLAN 10, 20, yes or no? But now we have a only 1 link. Getting my point? So what is the first thing? First answer is, if we have a concept of trunk, our this decrease the complexity. Yes, na everyone, our topology is very less complex, right? But before that was much complex. Clear? And second thing, higher cost also. Higher cost also. If you are using the more cables, if you are using the more physical link, definitely the cost will be high. Cost will be high. Getting my point? So guys, that was the problem if we do not have a trunking. Clear? But if we are using the trunk, what is the benefit? The first benefit is cost efficiency. Yes, we have a less cable. So that is definitely cost efficient. Getting my point? And our topology is also very less complex. Clear? Now there is a very simple question. For example, that is the switch. That is the switch. For example, here is the PC, 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 PC. Clear? All the PCs are connected like this. And for example, between the switches like this. Now, again, I ask you a very simple question. For example, that is VLAN 10, VLAN 20, and VLAN 30, VLAN 10, 20, 30. And that is the trunk link. Now, I told you this is the which link, guys? Access link or access port, right? Because on this port, now switch is only expecting VLAN number 10 data. Yes or no? Right now? So that's the reason that is the access port. And here, end users are connected. End users are connected. Here, on this port, switch is not expecting any other VLAN. Getting my point? Because on this port, you configure the VLAN number 10. So switch is only expecting the data in VLAN number 10 only. Clear? But that is the trunk link. And trunk link means why this link switch can share multiple VLAN data. Why this link switch can exchange the multiple VLAN data here. Getting my point? Everyone, yes or no? Right? For example, here 10.1, 10.2, 10.3, 10.4, 10.5 and 10.6. For example, here you are pinging from 10.1 to 10.6. 10.6. Clear? This PC send the packet, source IP address is 10.1, destination is 10.6. Packet reach on the switch. What switch will do? Switch check, I am receiving this packet on this interface. And this interface is the part of VLAN number 10. It means I need to forward this packet through all the interface that is the part of VLAN number 10. That is the by default behavior of the switch. But tell me one thing, on this switch right now, is there any VLAN 10? Answer is no. This is VLAN 20, 30, that is trunk. There is no VLAN number 10. Clear na? Everyone, yes or no? Right? But what is the rule? Rule is whenever switch will receive any packet on any access port, Switch needs to forward that packet through all the VLAN that is part of VLAN number 30, as well as switch will forward that packet through the trunk also, guys. Please remember these things. Clear? So switch receive this packet on this interface. Switch check in this packet. On this port, VLAN number 10 is configured. It means I need to forward this packet through all the interface. That is the part of VLAN number 10 as well as trunk. So this switch will forward your packet through the trunk port. Through the trunk port, packet reach onto the switch. Switch number 2. This is the switch number 1. Switch number 2. Switch number 2 receive this packet. Source IP is 10.1. Destination is 10.6. So switch number 2 receive this packet on this port. And this port is the trunk port. Agree everyone? Yes or no? Right? Now tell me how switch number 2 will understand where I need to forward this packet. Switch number 2, how switch number 2 will understand where I need to forward this packet. Because when switch open this packet, switch can't check your source IP and destination IP because switch is a L2 device, guys. Switch do not know your IP address. Switch is a L2 device, which do not know your IP address. So switch will check how switch number 2 will understand where I need to forward this packet. Here, here, or here. Where I need to forward this packet. Now, try to understand, guys. If we are using trunking, now, if anyone asks you how actually the trunking works, so please understand, trunking works on tagging. Trunking works on tagging. So when switch number 1 will forward a traffic towards switch number 2 via trunk link, switch number 1 must add the VLAN tag with this packet. What, guys? VLAN tag. Getting my point? Understand? So what it will do, switch number 1 is sending this, for example, that is the packet. Switch number 1 is forwarding this packet to the trunk link. But before forwarding, what switch number 1 will do? Switch number 1 will add here VLAN number 10 tag here and forward this packet towards switch number 2. Switch number 2 will open this packet. Switch number 2 will understand, oh, in this packet, the VLAN number 10 tag is there. Switch number 2 then immediately understand, oh, I need to forward this packet towards the VLAN number 10. Switch number 2 will check where is VLAN number 10 on this interface VLAN number 10. Switch number 2 will forward your packet through this interface, not here. Clear, guys? Everyone tell me yes or not. I hope you guys understand. Understand? So basically switch works, on trunk link, packet always be tagged. Packet always be tagged. Fine. So what is happening on the sender end here? Here what is happening? Your packet is encapsulating and here your packet is decapsulating. What do you mean by decapsulating here, guys? When switch number 2 receive the packet, this packet with the tag, switch number 2 will understand, oh, this part, switch number 2 will check the VLAN tag. Then after switch number 2 will understand, here I need to forward this packet. Now before forward this packet, switch number 2 will remove the VLAN tag and forward the actual packet towards the PC. So here what is happening? VLAN tag is here removing. And here what is happening? VLAN tag is adding. So that is called encapsulation and that is called decapsulation. Clear, guys? Everyone, I hope you guys understand. Clear? So on trunk link, basically this is the way how actually the packet is encapsulating and decapsulating. Now, if I ask you, who is performing the tagging here? Do you perform the tagging? Does we perform the tagging manually? Answer is no. We are not doing anything manually. We are not doing anything manually. Tagging is performing, guys, automatically. We are not doing anything. Now, if anything is happening automatically, definitely there will be some protocol. So please remember, in a networking, if anything is happening automatically, definitely there will be a either protocol or either algorithm. Clear? Nothing is happened automatically, guys. Okay. So for example, that is the trunk link. For example, that is the for example that this is the switch and this is the switch, and here for example that is the link. This is the which link, guys? Trunk link. This is which link? This is the trunk link. Clear? This is switch number 1, this is switch number 2, and this is the trunk link. So please remember, if any whenever any packet will forward, switch number 1 will add the tag and switch number 2 will remove the tag and forward the packet towards the exact destination. Fine. Now guys, this tagging is happening because of one protocol. Because of protocol. Clear na? So what is that protocol? So please remember, on trunk, there are two types of protocol we are using. First one is called ISL. Second one is called, guys, .1Q. What is? First one is called ISL. ISL means, guys, inter switch link. Clear? And second one is called, guys, .1Q. So basically, guys, these are the protocol that is responsible for tagging. Clear? On trunk link. Clear, guys? Everyone, yes or no? Clear na? Now, I tell you something about the ISL and something about the .1Q. So please focus. ISL. First point about the ISL that you need to understand. This is Cisco proprietary. It means this protocol is developed by Cisco, managed by Cisco. Done. So that's the reason it is called Cisco proprietary protocol. Clear, guys? Everyone, yes or no? Right? Now, if for example you are using here ISL protocol, whenever switch will receive any packet, switch will perform the tag. Tag means this is the original packet, and with this original packet, what ISL will do? ISL will add here its own header. Which header, guys? On header, ISL header. And in ISL header, there is a field called VLAN tag or VLAN ID. So don't be confused. Okay. Again, I am telling, see here, this is the original packet. This is, guys, original packet. If you are using ISL, what ISL will do? ISL will add here. What ISL will do? ISL will add here ISL header, and in this header there will be a many content, but among these content there will be a one field that is called VLAN ID, and that is called VLAN tag. Getting my point? So that's the reason your destination device, when receive this packet, your destination device will open the ISL header, and your destination device will check, oh, inside the ISL header, this is the VLAN tag, and in VLAN tag, there is the VLAN 10. It means I need to forward this packet towards the VLAN 10. I hope this is clear to everyone. Done, guys? Everyone. Understand? So this is called ISL. And please remember, ISL is, guys, Cisco proprietary. ISL is Cisco proprietary. Clear, guys? Everyone. Anyone here who don't understand?
It's clear.
Yes. So basically that is ISL. Okay. Now, one more thing. Again, you guys will ask, sir, there are two types of header you told me. One is ISL and second one is .1Q. But which header nowadays, which protocol we are using on the trunk? Guys, it's up to you. You can use ISL as well as .1Q both. This is Cisco proprietary and this is open. It means on any vendor device you can use the .1Q. But ISL you can use only the on Cisco. Fine. But even Cisco is telling, ki, hey, do not use ISL, use .1Q. Even Cisco is also telling, use the .1Q. The reason, what is the reason? Reason is, for example, that is the original packet. If you are using the ISL, if this is the original packet, if you are using the .1Q, see what is the difference. If you are using the ISL, what ISL will do? ISL will add here 30 byte extra data. For example, the size of your packet is 100 byte. If you are using ISL add 30 byte extra information. So total size of the packet is, guys, 130 byte. But if you are using .1q, your packet size is 100 byte. .1q add only 4 byte extra information. How many? 4 bytes. So total packet size is how many? 104 bytes. Now tell me, which one you guys will prefer? We prefer .1q because the size of packet is less. But if you are using the ISL, the congestion on the link will be high. The bandwidth utilization on the link will be high. Getting my point? So that's the reason we are preferring, guys, .1q, not ISL. I hope clear, guys. Understand? So that's the reason we are preferring, guys, ISL, not .1q. Done? Now, there are many content inside the uh, ISL, even inside the .1q. There are many content. Clear, guys? Everyone, yes or no? There are many content, but that is not our part. So we are not going to discuss the content inside the ISL. But for your information, if you want, for example, if you are using the ISL, we are using the DA, destination address. Destination address generally we are using, guys, multicast. What is multicast? Clear, guys? Everyone. Uh, we are using VLAN ID. We are using VLAN ID. By the help of VLAN ID, generally we can identify. We have a quality of services. We have a quality of services. So basically, there are multiple content inside the ISL, inside the .1q. Clear? But here, what we need to focus, guys, we need to focus on what is the use of these field. Clear? If you are using the .1q, in .1q, again, you guys will see the destination address. You guys will see there the VLAN ID. You guys will see there the priority field. You guys will see there the CRC also. Getting my point, everyone? Yes or no? Clear na? Yes. Understand, guys, everyone? So if generally when you use the .1q, when you try to open the .1q header, clear na? So there, for example, there is the field that is called TPID. What is TPID? Tag protocol identifier. What is tag protocol identifier? Getting my point? Now, one more field you guys will get there. TCI. Tag control identifier. Tag control identifier. Clear na? Here, generally, you guys will get quality of services like this. Clear, guys? Everyone, tell me yes or no. Is this clear, guys? Everyone? Understand? So basically, there are multiple content you guys will get. TPID. So basically, what is the use of TPID, guys? TPID, everyone. TPID is nothing. So please remember, in TPID, you guys will get the value 0x8100. This is the fixed value here you guys will get. What is the use of 0x8100? Because this field is telling you inside your packet something VLAN tag is attached. Something VLAN tag is attached. Getting my point, everyone? Now again, you guys will get the next field that is called PCP. PCP means priority code point. Priority code point. Basically, this field is used for the quality of services. Quality of services. Here you guys will get the value from 0 to 7. This is the something advanced, but I'm just telling you for your information. 0 to 7. 0 means less priority, 7 means high priority. Getting my point? Next thing you guys will get here, DEI. DEI, drop eligible indicator. Clear na? What do you mean by this? Basically, this field is telling us if any frame will goes drop in your network, basically this DEI field is used there. If something goes drop, clear? And the next one is you will get the VLAN ID. And I hope everyone know VLAN ID means this VLAN ID tells us about the which VLAN is there. VLAN tag is there. Clear, guys? Everyone, yes or no? Clear? Yes. And nowadays we are using, guys, dot 1q, not what? Not uh, ISL, because the size of ISL is uh, 30 bytes and the dot 1q is only 4 byte. Clear, guys? Everyone. Now, now the concept is how we configure the trunk. Guys, we configure the trunk first of all on the interface. We configure the trunk on interface. Okay, first point. So first of all, for example, you go on interface fast Ethernet 0 by 0. And what you need to do? You need to write switch port mode trunk. So this is the first command you need to write, switch port mode trunk. By this way, you can configure the trunk. Clear? But for example, if you are using the old version of switch, there you need to configure the encapsulation protocol is there. But nowadays, we are dot 1q is by default there. Clear na? But if you want to change, yes, you can change it. For example, you configure switch port mode trunk. If you want to use here, so either ISL or dot 1q, what you can do? You need to write the command, guys. Switch port trunk encapsulation, and after that you have a choice either ISL or dot 1q. Getting my point, everyone? Yes or no? Basically, that is the command by which you can configure the trunk. And if anyone asks you how can we check, the command is so interface trunk. By this command, you can check the trunk, guys. So interface trunk. So interface trunk. For example, come here in this topology. Come here on this device. Let me check. IP address is configured. Default gateway is also there. Clear? Here default gateway is also there. Here default gateway is also there. So on every device is, I think, configured. Let me check on switch show VLAN. So how many VLAN is there, guys? 10, 20, 30. 10, 20, 30, every VLAN is there. Okay. So interface trunk. See, trunk is configured here, guys. Trunk is configured here. Everyone, see very carefully. Trunk is configured. How can we configure, guys? Again, I am telling you. See here. Go to the, for example, I want to configure this port as the trunk port. How can you configure? You need to go interface fast Ethernet 0 by 7. And here you need to write switch port mode trunk. I write, guys, switch port mode trunk. Getting my point, everyone? Yes or no? Right? Then after, I need to change the, can you help me to explain more about ISL? Yes. See, ISL, basically ISL and dot 1q both are called encapsulation protocol. By the help of ISL, what you can do, you can perform the tagging of VLAN. Clear? But only difference is if you are using the ISL, it will add the 30 byte extra information with your packet. But if you are using the dot 1q, it use only and only 4 byte extra information. Getting my point, everyone? So that's the reason we are using dot 1q, not ISL. Clear? Understand, guys? Everyone? Yes or no? Clear, guys? Everyone? Okay. So this is the command by which you can configure this port as the trunk port. After that, for example, if you want to change switch port trunk encapsulation in, I don't know why it is not taking. What is the command, guys? Switch port trunk encapsulation. This command is not recognizing. Maybe here we do not have an option on packet tracer, we can change. but switch port, but command is this one. Please remember switch port trunk encapsulation, encapsulation, and then here when you press the question mark, here you guys will get ISL or trunk. Getting my point, everyone? Yes or no? Right? And how can you check, guys? Command is do show interface trunk. By this command, you can check here 0 by 6 and 0 by 7. These are the two ports. These are the two ports 0 by 7 and this one 0 by 6. Both are trunk port. These are the two ports that is called trunk port. Getting my point, everyone? Yes or no? Clear na? Understand? Now again one more thing, guys. But generally one thing, when you write the switch port mode trunk, what happened? All the VLANs is allowed. All the VLANs are allowed. Either you configure or not configure, no problem. Every VLAN is going to allowed. But in the real time environment, we are not doing like this, guys. In the real time environment, we are only allowing those VLAN that we are using. Getting my point? For example, in this lab, what are the VLANs we are using? Here VLAN 10, VLAN 30, 20, clear, and maybe 140. So only 4 VLANs here we are using. So we do not need to allow every VLAN. We need to allow only VLAN 10, 20, 30 and 40. Getting my point? See here, 10, 20, 30, 40 is allowed here in my case. But again, you guys will ask, sir, how can we allowed? For example, if I ask you interface, if I press the question mark, if I press the question mark, how can we allow the VLAN? For example, if I go interface fast Ethernet 0 by 7, here I am writing switch port trunk allowed VLAN, and here whatever the VLAN you want, you guys can write down here. For example, I want to write VLAN number 50. If I want to allow VLAN number 50, I write here VLAN 50. Done. Now see what is the problem here. I am writing so interface trunk. See here what happened. What happened, guys? On VLAN on fast Ethernet 0 by 7, only VLAN number 50 is allowed. But previously we allowed VLAN 10, 20, 30, 40 also. Yes, right? But those VLANs are now removed. Only VLAN 50 is there. That is the problem. Okay, but in real time environment, when you guys are doing this, please be careful. Otherwise, you will be in the very big trouble. Okay, so see, conft interface fast Ethernet 0 by 7. If you are writing switch port trunk allowed VLAN. For example, if you want to allow here VLAN number 50 or any VLAN, you must need to write here add keyword. If you are not writing the add keyword, only those VLAN will be allowed which you are writing right now, and rest all the VLAN will be removed. Clear, guys? Everyone. So please be careful whenever you guys will do in the real time environment. For example, here VLAN 50 is there already. I'm writing here add 10. Now see here do show interface trunk. Now see VLAN 50 is not removed. VLAN 50 is not removed. Getting my point? When I write the add keyword, see VLAN 50 is not removed. Only VLAN 10 is added here. Getting my point? I hope you guys understand. Clear? Switch port, trunk, allowed, VLAN, VLAN 10 and 50 is already there. I want to write VLAN 20, VLAN 30, VLAN 40. I write. You can write like this by putting the comma. Do show interface trunk. Now see, on 0 by 7, VLAN 20, 30, 40 is allowed. But see, here I didn't write the add keyword. So these three VLANs are allowed. But previously we allowed the VLAN 10 and 50. Both are removed. Getting my point? Everyone tell me yes or no. Right? For example, here I am writing VLAN 10, 30, 40. Now I am writing add. And now I am writing VLAN 10 and 50. VLAN, oh sorry, add VLAN, add 10, 50 like this. Do show interface trunk. Now see, VLAN 10, 20, 30, 40, 50 all are allowed now. So I hope you guys understand. in the real time scenario how we are processing these things. Clear? Understand guys, everyone? Yes or no? Understand? So what is the command guys? Show interface trunk. When you guys are write this command, by this command you guys can check the trunk interface. Clear? Now see. Here when you write this command, what are the things you guys are able to see? See na 0 by 6 and 7. These two ports are the trunk port. Mode is on. What is the encapsulation protocol we are using here? .1q by default. I told you by default nowadays we are using the .1q. What is the status? These are the trunking port. What this is called guys? Native VLAN. Now again we need to understand what do you mean by native VLAN? What do you mean by native VLAN? Try to understand. In the networking, there is a concept of native VLAN, guys. What is the use of native VLAN? Try to understand. So see, in networking, guys, there are called native VLAN. Guys, first of all, for example, this is the switch and that is the switch number 2. And if this is the trunk link, so if you are using the trunk link, it means whatever the traffic you guys are exchanging here over the trunk link, every traffic will be tagged. Yes or no? Because you are using .1q. Everyone tell me yes or no. Right? Right now? Yes, that will be tagged. But there are certain traffic that do not need to be tracked. That do not need to be tagged. Because for example, if you are sending any packet, for example, switch number 1, switch number 2, here PC1 and PC2, PC1 and PC2, like this. And for example, this is the part of VLAN 1020. If this PC is sending the packet, that should be tagged. Because here switch is receiving on VLAN number 10. That is the traffic that is related to the VLAN number 10. That is fine. But for example, if these are the two switches and these two switches are using certain traffic for to check its connectivity only. For example, switch number 1 is sending some packet to switch number 2 to check switch number 1, switch number 2 is up or not. And switch number 2 is sending some traffic to switch number 1 to check switch number 1 is up or not, to check just connectivity. So do you think for these type of traffic also do you need tagging? No, we do not need tagging for these type of traffic. Getting my point? Because these traffics are only used to check the connectivity. That traffic is not belongs to any certain VLAN. Getting my point, everyone? Yes or no? Getting my point, everyone? Yes, na? So in a networking, guys, on the trunk link, there is certain traffic that do not require the tagging. If you are doing tagging for these traffic also, it means you are increasing the bandwidth. You are increasing the congestion over the link. Getting my point, everyone? Yes or no? Right? Yes. Tell me guys, yes or no?
Yes.
Yes. Very good. So basically guys, there are multiple traffic. For example, here between switch number 1 and switch number 2, there are some traffic like CDP. CDP packet. Clear na? So CDP packet is just using the switch to check its connectivity, to check its neighbor device is up or not. Getting my point? Everyone, yes or no? Right na? So basically for CDP packet, we do not want any types of tagging. For example, STP. STP is used to check the loop. To getting my point? STP is not belongs to any VLAN. So for these type of packets, we do not want any types of tagging. For DTP, dynamic trunking protocol, we do not need any types of tagging, guys, for these type of packet. Getting my point? For VTP, for these type of packet, we do not want any types of tagging. So these type of traffic is not part of any VLAN. Getting my point, everyone? Yes or no? Right? So now again the question is, if these type of traffic is not part of any VLAN, then on trunk link, how switch will process it? So the answer is guys, by the help of native VLAN. By the help of native VLAN. So please understand, if this switch send any traffic towards switch number 2, and when switch number 2 will open that packet, and switch number 2 check C, and switch number 2 find this is the packet, and in this packet there is no tagging. There is no tagging. Then immediately switch number 2 will understand this packet belongs to which VLAN? Native VLAN. Which VLAN, guys? Native VLAN. So please remember, if in your network any packet that is not tagged over the trunk link, it means that packet belongs to which VLAN? Native VLAN. Clear, guys? So basically native VLAN, what is the use of native VLAN, guys? Native VLAN is basically carry the untagged traffic without VLAN. Getting my point, everyone? Yes or no? Right? And I told you in yesterday class, by default, VLAN number 1 is configured over the trunk. Sorry, on the switch. By default, all the ports is the part of VLAN number 1. So by default, VLAN number 1 is the native VLAN on the switch. Which VLAN, guys? Native VLAN is VLAN number 1 is called native VLAN. Clear, guys? Everyone? Yes or no? Right? Yes. So, but what is the precaution? Precaution is whenever we configure the native VLAN, we have to use any unused VLAN in your network. VLAN number 1, for security reason, we are not using as a native VLAN because everyone know VLAN number 1, right? So for security reason, we are not using VLAN 1 as the native VLAN. Clear? Now, one more concept that is very, very important. That is switch number 1. That is switch number 2. Here you are using the trunk link. So if you are using the trunk link, it means either you are using the ISL or either you are using the .1q for tagging. Yes or no? Everyone tell me. Right? So if you are using the ISL, it does not support the concept of native VLAN. It does not support the concept of native VLAN. It means if this switch is sending the CDP, if this switch is sending the VTP, DTP, every packets, these packets should not be tagged. But if you are using the ISL is going to tag this traffic also. So now you guys can assume if you are using the ISL, how much congestion will be over the link. Yes or no? Understand? Hey, everyone, yes or no? Right now? Even only ISL, even itself ISL is adding the 30 byte extra information. And after that, ISL is tagging this type of traffic also. So you can assume how many traffic bandwidth utilization will be there. So that's the reason we are avoiding ISL, guys. That's the reason we are avoiding ISL. We are not using the ISL in the real time. Rarely you guys will see in the ISL in any company. Nowadays, we are using .1q. .1q support the native VLAN. It means for these type of traffic, .1q is not going to perform the tagging. .1q is not going to perform the tagging. Getting my point? Everyone, I hope this is clear to all of you, right? So guys, that is called native VLAN. So whenever we configure the native VLAN, what is the best practice? Avoid first of all VLAN 1. Getting my point? Everyone. And always use the dedicated VLAN. For example, any unused VLAN you guys can use as a native VLAN. Clear? So that is the first point. First best practice is avoid VLAN 1 as a native. Second, use any unique or unused VLAN. Unused VLAN as a native VLAN. Third thing, please remember, that is very important. Switch number 1, switch number 2. If you are using here, for example, 111 as a native VLAN, here must you need to use the same VLAN as the native VLAN. It means native VLAN always match on both sides. Clear, guys? Everyone, yes or no? Right? Otherwise, you guys will get the error of native VLAN mismatch. Okay, that will be the problem. Clear, guys? Everyone, yes or no? Clear na? So that is the use of native VLAN, guys. For example, here, come here on the switch, and you see here, what is the native VLAN here, guys? VLAN number 40 is the native VLAN. What is the native VLAN, guys? VLAN number 40 is the native VLAN. We are on switch number 2. We are on switch number 2. Interface fast Ethernet 0/7. What is the command to change the native VLAN? Switch port trunk, native, VLAN, and for example, right now VLAN 40 is there. I'm writing VLAN 30. And I'm writing do show interface trunk. When I write this command, what is the native VLAN now? VLAN number 30 is the native VLAN, guys. What is the native VLAN? VLAN number 30 is the native VLAN. Clear, guys? Everyone, yes or no? Now see, I am getting the error. I told you, na, because here on this switch, I am using the VLAN number 40 as the native VLAN. Getting my point? And here I configure VLAN 30. So that's the reason I am getting this error. Native VLAN mismatch. I hope this is clear to all of you. Everyone, tell me. Right? Clear? So here I am writing VLAN number 40 to solve this problem. I hope you guys understand the concept of native VLAN also. Done, guys? Now see very carefully. Let me check if we can do something. Okay. For example, that is here I go. I'm writing ping. I'm writing ping 192.168.1.1. 1.1. So I am pinging from here to here. Fine. This generate the ARP reach onto the here. What I told you, na, whenever switch receive any packet, switch will forward this packet to the trunk port, right? So this is the trunk link. This is the trunk link, right? So switch is forwarding towards the trunk. Packet reach onto the router, right? Because we configure the default gateway here, guys. We configure the default gateway. Here we configure the default gateway, right? Everyone. Now again, you guys have confusion. Okay, sir, how you configure the default gateway here? Because right now here on the router, you are using only one link. You are using only one link, sir. Yes or no? Everyone tell me. Right now, here I am using only one link. And I configure how many default gateway? 3 default gateway. For VLAN 10 different, VLAN 20 different, and VLAN 30 different. Guys, this is possible because on router, you have a facility or feature that is called sub-interface. What is called, guys? Sub-interface. You can create here sub-interface. You can create sub-interface. Getting my point, everyone? Yes or no? You can create sub-interface. Let me show you. I go to the router. I'm writing the command show IP interface brief. See, I configure once. See, by default, the interface is here. I am using gig 0 by 0. That is physical interface. That is gig 0 by 0. Right. And from gig 0 by 0, I created 3 sub interface. Gig 0 by 0 dot 10, gig 0 by 0 dot 20, gig 0 by 0 dot 30, and gig 0 by 0 dot 40. I created total 4 sub interface. Getting my point? I use here 10, 20, 30 according to the VLAN. For example, I use this gig 0 by 0, this interface for VLAN 10. So that's the reason I use here 10. I use this interface as the VLAN for 20. So I use here 20. Getting my point, everyone? Yes or no? Clear na? If again, if anyone asks you, how can you configure? How can you configure? How can you answer? Anyone? Anyone know how can we configure the sub interface? Anyone? 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 Anyone?
I don't know.
Sorry, no one? Oh,
No one, no one. I don't know.
okay, cool. No problem. What you need to do, you need to go into the global configuration mode. Okay. On, for example, gig 0 by 0 is already there. Okay. For example, what you need to do, you need to write interface gig 0 by 0 and then put the dot. And for example, dot 40 is already there. Okay. I'm writing dot 50. So that is the interface. That is the sub interface. Clear? And whatever the IP address you want to assign, you can write IP address. For example, I want to write 10.0.0.1. 255.0.0.0. Getting my point, everyone? Yes or no? Clear na, everyone? Right? I write this one and then I write no shutdown. Exit and see here. Show IP interface brief. See na, for 0 by 50 is created. Yes or no? IP address is not assigned. Maybe some problem. But yes, by this way we can do it. Are you getting my point, everyone? Yes or no? Tell me. Understand
Yes,
na? Yes.
yes.
By the
Each VLAN I should create sub interface, sub VLAN.
sorry, for some, yes, for any VLAN you can create the sub interface.
So okay, thank you.
Clear, guys? Your packet will reach onto the router. What router will do? Router will perform the again routing. Again routing. See, router forward this packet towards the switch. What switch will do? Switch will forward this packet to the PC again back, because this is the ARP packet. Now PC is sending the ICMP. ICMP reach to the router. Getting my point, everyone? Yes or no? Right? Router receive this packet. When I open this packet, see now, this is the again ARP. Why? Because this router is needs to solve the MAC address between this PC to this router. Okay, so see now, ARP packet will exchange here, 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 here. This is the which packet, guys? Let me open it. ICMP packet. This is the ICMP packet. Getting my point, everyone? Yes or no? This is the ICMP packet. Clear? In ICMP packet, source IP is 192.168.66. That is the source IP address. Destination is 192.168.1.1. Clear, clear, clear. That is the L2. That is the L2, layer number 2. Here in layer number 1. Sorry, in layer number 2, when you see the outbound packet, outbound means when switch is forwarding this packet towards the router. See very carefully. In this packet, I hope you guys are able to see one thing. TPID and TCI. TPID and TCI. What is this? Who can tell me? TCI means, guys, tag control identifier. What is tag control identifier? In tag control identifier, what is the value? Who can tell me? 0x0014. What is the value, guys? 0x0014. When you see, when you check here, convert hexadecimal to decimal. When you choose any tool, what is the value, guys, here? 0x0014. What is the value you guys are getting here? 20. What do you mean by it? It means when this switch receive the packet here, and when this switch is forwarding this packet towards here, what switch is doing? Are tell me yes or no? Tell me. This is the trunk link. Agree? Yes or no? Tell me. Right? Switch receive this packet on this interface. Switch is checking, I am receiving this packet on this interface, and this interface is the part of VLAN number 20. So when switch is forwarding this packet toward the trunk, what switch is doing? Switch is adding the VLAN number 20 tag here. And this packet is received on. This packet is received on router. Getting my point? I show you guys everything. Yes or no? Clear na? Understand? So router receive this packet. See? Getting my point? Now let's open this packet. This is the inbound. Inbound. What is the track control identifier? 0, 1, 4. Clear? Come here, outbound. In outbound, what is the value? 0, 0. A. Why? Because, see, tell me one thing. You are pinging from here to here. This is belongs to which VLAN? VLAN number 20. And this belongs to which VLAN? VLAN number 10. It means you are pinging from one VLAN to different VLAN. Yes or no? Right? Packet reach here on the switch. Switch receive this packet on this interface. What switch is doing? Switch is adding here VLAN number 20 tag here and forwarding this packet towards the router. Right? What router is doing? Router receive this packet on this interface. Router check in this packet. in this packet, the tag is VLAN number 20. Fine. After that, router needs to perform the routing. Getting my point, everyone? Yes or no? Right. Now, what router do? Router check. I need to forward the destination IP is 192.168.1.0. This one. Right. And on this network is configured where? This network is configured on gig 0 by 0.10. Yes or no? Everyone. Right? On this interface, and on this interface what you did, you already configure what? I show you one thing. I here on this interface I already configure one command. Let me show you. So running configuration interface gig 0 by 0.10. Oh, it is not accepting, but see, no problem, we can see here. See very carefully, guys. On gig 0 by 0.10, here I configure one command, that is encapsulation.1q10. It means I am telling to this router, whenever you receive any packet, and if you perform the routing, and if you are forwarding this packet, why 0 by 0.10, what you do? You just add the VLAN 10 tag with this packet. Encapsulation.101q. I am telling to this router by this command. And again on the router I configure this one. I am telling the router, if you are forwarding this packet y 0 by 0.20, then add please VLAN number 20 tag. Getting my point, everyone? Yes or no? Right? Why I am telling this one? Try to understand. This is the router. This is the switch. And this is, for example, PC. And this is the trunk. When this PC send the packet reach onto the switch receive this packet on VLAN number 20. Switch is forwarding this packet with VLAN number 20 tag. Router receive. Clear? Now router perform routing. After perform routing, router find, oh, the destination IP address is 192.168.1.0, and this is connected on gig 0 by 0.10. It means I need to forward this packet by gig 0 by 0. Done. It means this router send the packet back towards the switch. Fine. Why? Which interface? Gig 0 by 0.10. But tell me, if this router will not tag the packet reach onto the switch, that switch will understand where I need to forward the packet without tag? Answer is no. How switch will understand where I need to forward the packet? By the help of tag, guys, because here this link is trunk link. So that's the reason on gig 0 by 0 you configure encapsulation protocol here. If you do not run this command, this switch is not going to understand where I need to forward this packet. Getting my point? So that's the reason here I configure encapsulation.1q tag. So now when this router will share the packet by gig 0 by 0.10 with this packet, switch will add the VLAN number 10 tag here. So when this switch will receive, this switch will now understand, oh, I need to forward this packet towards here. And when this switch will forward this packet towards here, switch will add the VLAN number 10 tag here and then forward towards the switch. I think this is clear to all of you, everyone. Yes or no? Clear na? So see, packet reach here, switch, what switch will do? See here, I open this packet. Switch inbound. In the inbound, switch receive the TCI. TCI is 0x000A. That is nothing, guys. This is 10. You can convert it. Okay. Outbound. In outbound also what is? A. It means now what switch is doing? Switch receive the packet from router, and with this packet router add the VLAN 10 tag here. Fine. That is inbound. Now switch is forwarding this packet towards here with the VLAN number 10 tag here. Clear? So that's the reason if you do not perform the tagging here, this switch is not able to forward your packet towards, this switch is not able to add the tag, guys. So packet reach onto the switch. Now switch will check, I am receiving this packet on this interface, and in this interface, the tag is 10. Tag is 10. It means definitely that this belongs to VLAN number 10. Clear? So this switch needs to forward this packet either here or either here. Getting my point, everyone? Yes or no? Right? After that, what switch will do? Switch will check what is the destination MAC address. The destination MAC address is 0C01, right? This switch will check which table? MAC address table. Show MAC address table. In the MAC address table, what is the destination MAC address, guys? 0C01. Where is 0C01? 0C01, that is the part of VLAN 10, and that is connected on fast Ethernet 0/6. So where is 0/6, guys? Where is 0/6? Where is sorry. Where? Switch. 0 by 0C01. 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 Oh no, sorry, guys. Destination is 9916. What is destination? 9916. Where is 9916? Here 9916. And that is connected on fast Ethernet 0/1. Right? It means this switch needs to forward the packet by 0/1. Here is 0/1. So this switch will forward this packet by 0/1. I hope this is clear to all of you. See, switch forward this packet towards 0/1, and the communication is successful. Clear, guys? Everyone, I hope you guys understand how we configure the trunk and exactly how trunking is work, what is ISL, what is .1Q, how we configure the ISL, how we configure the .1Q, what is the difference between ISL, what is the difference between .1Q, what is native VLAN, how we configure the native VLAN, and how we can make communication possible between the different VLAN, right? How we can configure the sub interface on a router. I hope you guys understand each and everything very clearly. Clear, guys? Everyone?